In this video, we will learn how to solve compound inequalities. For this example, we're going to do compound inequalities of the form a is less than x is less than b. That means that x is between two values. This double inequality is the same as an and statement. This can be seen as a is less than x and x is less than b. So let's start with example 8a. Our goal here is to isolate x. Since now we have a left, a middle, and a right side, and x is in the middle, what we do to the middle, to leave x alone, we must do also to the left and to the right. So let's see if we can figure this out. I have 3x minus 7 in the middle. First, I'm going to move, just like before, anything that is being added or subtracted. So I need to move this minus 7. So the way that we move a minus 7 is to add 7 to the middle, but now we also add 7 to the left and add 7 to the right. So negative 4 plus 7, different signs. We subtract and keep the sign of the largest, so that is 3. Bring the inequality. In the middle, negative 7 plus 7 will get eliminated, leaving us only with 3x. Bring the inequality, and on the right side, 8 plus 7 will be 15. We're not done yet. This x has a coefficient of 3. This 3 is multiplying x. So in order for me to isolate x, I have to get rid of this 3 by dividing. So I'm going to divide the middle by 3. And what I do to the middle, I do to the left, and I do to the right. From left to right, 3 divided by 3 will be 1. Bring the inequality. In the middle, 3 divided by 3 again will be 1x, or just x. And then on the right side, 15 divided by 3 will be 5. So what does this mean? How do I go from the inequality to the graph to the interval notation solution? Well, this one is read that x is between 1 and 5. So then I'm going to go and find 1 and 5. And since x is between 1 and 5, I'm going to shade between 1 and 5. So let's do that. I'm going to shade between 1 and 5. And then I come back. Since I am including the 1, I place a square bracket on the 1. Since I am not including the 5, I place a parenthesis on the 5. And this becomes our solution. Remember, we read it from left to right. So our solution is between 1 and 5. I include 1, but I don't include 5. And that's a solution for 8a. Let's try another one here. Just like before, x is in the middle of this inequality. My goal is to leave x alone, to isolate x. So first I move anything that is being added or subtracted. So then I'm going to subtract by 2. But what I do to the middle, I do to the left, and I do to the right. From left to right, negative 6 minus 2, same sign. We add and keep the sign. That's minus 8. Is less than or equal to. This gets eliminated, leaving you with minus 4x. Is less than or equal to, well, on the right side, 2 minus 2 will be 0. Not bad. I'm not complete. This x has a minus 4 being multiplied. So I divide by negative 4. What I do to the middle, I do to the left, and I do to the right side. From left to right, negative 8 divided by negative 4 will be positive 2. In the middle, negative 4 divided by negative 4 will be positive 1x, or just x. And on the right side, 0 divided by negative 4 will still continue to be 0. The only thing that we have to be very careful here is that we divide it by a negative. So since we divided by a negative, we must flip our inequalities. So then this will become greater than or equal to. What does this mean for us? This is still saying that x is between 2 and 0. But because our inequalities were flipped, we're going to flip this entire statement so that we move from left to right, from smallest to largest. So the way I flip this inequality is by writing the 0. Then I write the x. and then I write the 2. Notice how between 0 and x, the opening side is towards x, so we do that. And then between x is 2, the opening side of the inequality is towards the 2. And now we have our values from smallest to largest, being careful with the inequalities. So what does this mean? That means that x is between 0 and 2. And you might be saying, well, that's the same thing as before. X is still between 0 and 2. Yes, that is correct. And we actually don't have to do this step. The reason why we did this step is because it helps us out when we are moving it to the number line. Sometimes I've seen students that create a number line and they place the 2 on the left and then the 0 on the right because this is what the inequality has. But in a number line, this is incorrect. You notice the 0 is on the left and the 2 is on the right. So this is the only reason to do this step, to make sure that we have the numbers from smallest to largest. In any case, the solution will be between 0 and 2. So let's go shade that. Between 0 and 2. And we are including both values, so we place a square bracket to both, making our solution from left to right from 0 to 2. Square brackets on both. Thank you so much for watching, and I'll see you in the next one.